So, good evening, everyone. Welcome to Cosmic Zoom. So, Cosmic Zoom, as you might know, is a digital exhibition by ICTS, and it explores some amazing questions and topics at very different scales. So, please visit www.cosmic-zoom.com .in to know more about this exhibition. Please do. People have worked really hard to put this together. We would really love for you to have a look at it. And for today, we have our speaker, Vijay Ramesh, who's speaking from the Nilgiris, and he's a PhD student at Columbia University, USA, where he studies how climate change and landscape changes impact bird species in the Western Ghats. And he's also the co-founder of an initiative called Project Dhvani, which uses sounds to monitor biodiversity. And this is what he's going to be talking to us today, where he's going to tell us how acoustic technology is used as a conservation tool. So over to you, Vijay. Please go ahead and introduce us to this amazing project of yours.
Thanks, Ipsita. I'm just going to share my screen now, and then we can get started. 1 second. Okay, great. Can you all see this?
Yes, it is visible.
Yeah, okay, great. Thanks again, Ipsita, and thanks, Bertie, and the entire ICTS team for inviting me today to talk about something that I'm really passionate about, which is using novel tools such as acoustics to monitor biodiversity. As Ipsita mentioned, I'm currently pursuing my PhD in ecology and conservation biology at Columbia University. And here I'm broadly looking at how landscape and climatic changes primarily across the Nilgiris and the Annamalais is affecting birds. And to do that, we're using a range of tools ranging from acoustics, which I'll talk to you about today, and satellite images and historical data and citizen science data to inform biodiversity conservation. So today I'll be specifically talking about I'll be specifically talking about Project Dhvani, an initiative that we had started a few years ago, and where we are primarily using acoustics to monitor biodiversity across human-modified landscapes. But before I tell you a bit more about Project Dhvani, I thought let me tell you a bit about bioacoustics in general. Right? So I'm going to take you to the heart of central India. Let's assume that you're in Kanha right now and you're on a jeep safari. And the first thing you notice here is that there's a jackal staring right back at you. And this is a pretty quintessential image when you go on a safari, because you're on this muddy road and you're looking at wildlife through your jeep and through your binoculars and your camera and other lenses. And you see the dry forests of central India along with wildlife that reside there. Right? But just for a minute, let's imagine that, just perhaps close your eyes and let's look at this entire picture from a completely different perspective, which is sounds. So maybe you might hear sounds of leaves rustling against the wind, or maybe insects calling depending on the time of the day, or even something like the pitter patter of sambar or other deer moving through this landscape. So we associate different terms with the sort of sounds we hear. For instance, if you're hearing rain or wind, etc., people call it geophony, right? Don't bother too much about these terms, but the point I'm trying to make here is that there are a variety of sounds that you hear when you're in a particular landscape, such as this beautiful forest in central India. Perhaps you're hearing a lot of bird calls, which we term as biophony. And at the same time, you're probably making a lot of noise sitting in your jeep, moving around your camera, trying to photograph the jackal, right? So we call that anthropophony. And bioacoustics is essentially the science of using sounds to inform ecology and broadly, I would like to think more so conservation today. And I'll tell you a bit more about it as we go through my presentation. And here I'm going to play 2 more clips, and I'm going to take you from Central India to the Western Ghats, where I primarily work. And I want you all to think about what's the first thing that comes to your mind when you hear these 2 audio clips, anything that comes to your mind, right? So I'm going to play these 2 clips now. This is the first one. Okay, that was the first one. This is the second clip. Okay, the second one is a bit more feeble, but I just want to know if someone's commented in the YouTube section or on Zoom, anything that came to their mind. Please don't be shy. Just think about whatever came to your mind when you heard these 2 clips. Yeah.
So Vijay, we do have some comments
Sure.
on.
Yeah.
So somebody, Zenith Afreen says it sounds like the bird sanctuary near a waterfall. Murli says it sounds like a hornbill. And there's another sad person, that would be me, because I I have just complained that I live in Bangalore and I hear only traffic sounds. So this sounds really nice.
Okay.
Tanya says she heard lots of birds, so she thinks it was taken during the night.
Okay. Thank you all, and thanks, Bertie, for reading out those comments. In fact, I would say all of you are right and wrong in certain aspects, but right more or less in that, you're hearing a variety of sounds in terms of the clips I played. So, in fact, the first clip I played is coming to you from a rainforest in the Animalize, especially the Valparai Plateau. And this is coming from a protected area rainforest site, specifically the Animalai Tiger Reserve. And so the first thing you might see when you look at this picture is, the density of all these trees and the understory and the shrubs and ferns and overall the vegetation, looking so dense in this particular landscape, right? And the same sound that I played to you can also be visualized in what we call as a spectrogram, which is nothing but visualizing acoustic data in terms of frequency and time. So you can think of time on the x-axis, where you have time going from 0 to 30 seconds here, and frequencies on the y-axis. So you can probably hear a number of birds. So for instance, the greater racket-tailed drongo making its, that ting ting, the sort of like a clanging of bells sound, and you probably heard some sunbirds and some fulvetas, etc. So there's a lot of activity happening here at this site, right? So the second clip I played to you is coming from the same region, but from a completely different habitat type. So in front of you, you can actually see a timber plantation, primarily consisting of eucalyptus. And you can see that the spectrogram looks a little more empty. So you probably heard a scimitar babbler, and perhaps there are some insects vocalizing at high frequencies, which we probably are not able to hear. But the point I wanted to illustrate here is that the 2 habitats are so distinct that there is differences in biodiversity that reside in these 2 different habitats, and that is actually known to us through the audio recorders and the acoustics that we collect. So you can probably stop me here and ask, why acoustics though? Why not carry out a standardized, an ecological design? You are an ecologist after all, right? Why are you relying on technology? Well, a couple of years ago, I was in the Valparai Plateau in the Animalize, and here you can see my colleague carrying out what we call as a point count. So she's basically in a given location, and she's observing and recording all the birds that she can hear and see in a given particular duration. So we usually take 15 minutes as a standard duration and we are standing in the middle of this forest site, and we are recording all the birds we can see and hear, right? And our field collaborator and field assistant is actually looking out for us so that there are no elephants or gore close by. But one of the first things that I noticed when you're in a tropical rainforest is majority of the biodiversity that we hear is often, majority of the biodiversity that we're trying to see is often heard and never really seen. In fact, over 90% of the birds that we record in the Anomalise is detected orally. And so that got me thinking, what if we were to use a different tool that which such as acoustics or an acoustic recorder shown here in this picture that can be deployed at multiple locations at the same time, and we can perhaps collect thousands and thousands and thousands of hours of recording, which we can then process in using the computational resources that we have today, right? So, but why acoustics now? Well, I would like to say that habitat loss is a key concern, and while we can continue carrying out our standardized designs of monitoring biodiversity, we really need tools that can rapidly monitor the effects of deforestation and conservation, and essentially aid conservation. And I would like to make the case that one such tool is acoustics. And acoustics has been, or rather the field of bioacoustics has been around for a while. And acoustics as a conservation tool is something that people are thinking about a lot more in tropical countries, especially one like India. So for example, the picture on the right is basically a spectrogram again. So we call it a soundscape if it's essentially all the sounds that come from a particular landscape, right? So my colleague here, Zuzana, she's been monitoring biodiversity in the forests of Borneo for a while now, and Borneo has seen really high rates of deforestation over the last couple of decades. So she's been placing these recorders in forests that have been logged and forests that are pristine, untouched, etc. And she's been noticing these patterns that over time, we see that forests that have been logged are tending to lose more and more biodiversity as time progresses, while forests that are primarily pristine are more or less having biodiversity, or rather the soundscape seems to be similar over time, but that remains to be seen, as the effects of climate change are still something we need to look at. But acoustics can actually not just be used, as I mentioned earlier, just at a single location, but we can perhaps compare it across different locations. Imagine comparing the acoustics of forests in central India to the acoustics of forests in the Western Ghats. And that's something that we were really keen on doing, right? And so moving forward, as climate change and habitat loss act concurrently, I really think we need to use a rapid assessment tool or a tool like acoustics to help us, monitor biodiversity and thereby aid conservation in the long run. So keeping this in mind, in 2017, my colleagues and I decided to start Project Dhvani. And Dwani is the Sanskrit word for sound, and sound is what this initiative is all about. And our aim was to essentially monitor biodiversity specifically across human-modified landscapes of central India and the Western Ghats. So today I'll be telling you a bit more about an area that I'm more familiar with, which is the Western Ghats. But in this particular project, we are currently recording biodiversity, or the sounds that biodiversity emanate across the Western Ghats and central India, as I mentioned previously. So I'm going to take a slight detour here and take you to the Annamalai Hills, which is the region I primarily work in, along with the Nilgiris, where I currently am. So if there's been any lag in video or audio, I sincerely apologize because I have a spotty connection. So the Annamalai Hills is in the southern Western Ghats, and the Western Ghats is a long mountain range that runs along the southwestern coast of India and is home to extraordinary levels of biodiversity, and is also home to large human populations. And I think it's really fascinating that in India in particular, we have achieved some level of balance, even though there's plenty of human wildlife conflict. I think there's some level of not just balance but also cultural tolerance towards wildlife in general, and I think that's really fascinating to me. And I wanted to look at it from an acoustic perspective, hearing all those jeep sounds, those sounds of lorries turning across a hairpin bend, and at the same time, a Malabar whistling thrush is just singing. And I think that's just fascinating. So, talking about humans, these two landscapes have seen a ton of anthropogenic changes over the last few decades, especially in terms of habitat loss. So, in the panel on the top right, you can see an outline of the Nilgiri Hills, and you can see how the landscape has changed from 1973 to 2017. And I'm sorry, the legend is not very large, but essentially you can see that a lot of timber plantations, especially eucalyptus and invasive acacia, which the British planted here in the early 1850s, have pretty much taken over large swathes of this landscape. And that is the same case for the Anomalais and the Palni Hills. And you can see that it's really stark in 2017 as you go from 1995 to 2017. So as we are seeing these changes, or as we are witnessing, these changes in real time, I wanted to ask, how do these changes really impact biodiversity, right? And specifically, I wanted to look at birds, a taxa that I'm familiar with and a taxa that I love, because birds range across different habitats and occupy, in fact, different areas of vegetation, or rather, for example, you can hear certain birds always calling from the canopy of a forest, while certain birds always forage in the understory. And birds could be potentially used as an indicator taxa to tell us a bit more about how changes around them are affecting their presence. Right? So, keeping that in mind, especially in the Anomalais, I wanted to show you what this landscape looks like, so it gives you a better picture of how this mosaic of forests and human modified land cover types are present and how they impact biodiversity. So in this picture, you can see a protected area in the far back, which is the Anomalai Tiger Reserve. You can see a forest fragment in the midst of a tea plantation, which is pretty fascinating. And in fact, such small forest fragments actually hold tremendous amount of biodiversity. Another picture to illustrate my point here, there's this beautiful mosaic of forests and tea plantations, and basically a sea of tea and forests, if I can put it that way. But this landscape is, as I mentioned earlier, again, it's like there's an island of there's a forest that's basically in the middle of tea all around it, and these forests are also home to a lot of biodiversity, including these gentle giants that basically go through these tea plantations to go from one forest fragment to another. In fact, I was lucky enough to see these two elephants just cross a particular fragment on my left to a fragment on the right, and it's just amazing how biodiversity, large mammals such as elephants have actually adapted to landscape changes in this particular region. And as we were recording this, elephants seem to just care about moving from one particular patch to another, without really caring about all the humans that are watching this and recording this particular site. Right? But of course, it's not just large mammals. It's also my favorite taxa, which is birds. We have a range of birds, including raptors and birds that form large flocks, like minivets, to birds that sing constantly in the rain, like the Malabar whistling thrush in the center, to even birds that form socially complex groups, like the scimitar babblers, and migratory ones on my far right, like the chestnut-headed bee-eater, which comes. I'm sorry, I'm not very sure where exactly the bee-eaters come from, but definitely far north of India. Uh, so in this particular landscape, since there has been quite a bit of degradation, the Nature Conservation Foundation, a nonprofit that I collaborate with, have been restoring degraded forest fragments since 2000. And here's an image of a forest fragment on my left that was taken in 2008, and I titled Before. And here's another image that was taken from the exact same angle in 2020. So you can see a stark difference in terms of how active restoration of these degraded forest fragments can impact flora, that is, and vegetation overall, right? And this year is the 20th year, or sorry, it's all 20th years just gone by, but it's been 20 years since the nonprofit has been restoring forest fragments across this plateau. So I thought it might be a really nice design where you can actually ask, how does biodiversity vary as we restore these forest fragments? While people have looked at tree species, people haven't really looked at faunal biodiversity, especially birds or mammals or amphibians, for example. So just to remind you, we have this beautiful setup where we have actively restored forest fragments on my left, and in the middle you can see what I call as passively restored forest fragments, which is basically abandoned forest fragments in the middle of T. So there isn't much degradation happening there, but at the same time, we aren't really carrying out active restoration of that fragment, right? And of course, on my right is the benchmark, which is a protected area, which is the Annamalai Tiger Reserve, which surrounds the Valparai Plateau, where my study was carried out. Okay. So how do we go about doing this? Well, one of the questions we really wanted to ask was, how does the number of birds that we see vary from these actively restored fragments to passively restored fragments to our benchmark sites? So we thought one way to look at that would be, and to increase our efforts, would be to use acoustic recorders, right? So here I'm showing you two different recorders that we've been using. One is the Swift recorder, which, since the size is pretty large and it can actually you can actually attach multiple microphones, the radius that it captures is much wider compared to the audio moth that I'm showing you on the right. But the audio moth is pretty small and compact that I can actually probably take like 30 of them in my small backpack and place it across different sites in a single day and just be back to my field station, right? So there are a lot of advantages and disadvantages depending on what recorder you want to use, but you can always ask me more about it later. So we had about 43 unique locations or sites in the Annamalai Hills, specifically the Valparai Plateau, which is about 1,300 meters above sea level in the Annamalai Hills. And here I want to stop here and actually acknowledge the efforts of my collaborator and my project student, Akshay Anand, who's been going through thousands and thousands of hours of recordings that we've been collating from the sites in the Annamalais. And he's been going through each clip individually and annotating, is there a scimitar babbler? Is there a red-whiskered bulbul? Is there a Malabar whistling thrush? And he's been doing this for a lot of our recordings, and the work continues. So thanks, Akshay. And before I tell you a bit about what we've been finding so far, we in fact placed our recorders to collect data from each of our sites for about 7 to 15 days of continuous recording. So it's a lot of data, as you can imagine. And processing it is a whole another question that you can ask me later on. But we're still trying to figure out how to best use the computational resources that we have. And we decided to capture 2 different seasons, because in the winter, as you can imagine, a lot of birds come from further north in the Himalayas, or even all the way from Russia, actually, to spend their winters in better climes, especially in the Western Ghats. And in summer, they go back to their breeding grounds, to wherever they were from. Right? So here we captured, collected data across these 2 seasons from March and last year to Feb of this year. So I'm just going to show you 2 slides. These are the only 2 slides that have some data and analysis associated with it. So just bear with me for a moment. So I'm going to show you data that we've been analyzing since the data that we got in the summer. So here, I'm going to show you the total number of detections of different species on the y-axis. And on the x-axis, you can see different treatment types or restoration types, right? So we have our actively restored fragments, our benchmark sites, and our passively restored fragments. And what we decided to do here is split the species that we see as rainforest specialists and open countries generalists, right? So birds like red-whiskered bulbuls or common tailor birds or oriental magpie robins, birds that you commonly see in Bangalore and other major cities in India, can be considered as open country generalists, while rainforest specialists are ones like the picture shown here is the Malabar drogan, which primarily occurs in, pristine benchmark sites and sometimes at the edge of coffee plantations and forest sites as well. So an interesting result that we see here, which is pretty encouraging, is that if you focus on the violet boxes for a second here, you see that the number of detections of rainforest species is the highest in a benchmark protected area site. So that's expected, right? But the second highest number of rainforest detections of rainforest species that we see are actually in our actively restored forest fragments compared to our passively restored sites. So this actually goes to say that active restoration does impact faunal biodiversity as well, and plays a pretty important role in bringing back birds that were formerly occurring in some of these sites. On the other hand, if we look at some of our passively restored sites, or the brown boxes here, as expected, some of our passively restored sites, in fact, all of you saw that first image of a timber plantation that I showed you, right? Eucalyptus, where it's a pretty open site and there isn't much canopy cover and there isn't much dense vegetation and there aren't a lot of variety of different tree species. So often you see a lot of open country genderless birds in such sites. So the red-whiskered bulbul, here I've just shown you that picture for illustration. But in our passively restored sites, we saw a larger number of open country species relative to our, actively restored sites, and the lowest in our benchmark sites, as expected. So this result is pretty encouraging to us, but we decided to take this one step further. And I'm going to show you something that we recently developed, which is what we call as acoustic space use. So let me just explain this to you for a second. Imagine you're hearing all these sounds throughout a given day, starting at midnight and ending at midnight the next day. And on the x-axis is basically frequencies. And here, what we'd like to call acoustic space use is basically what's the overall level of acoustic activity in any given frequency bin over time, right? So to illustrate this point better, often between 6 a.m. to probably about 6 p.m., you're probably seeing a lot of bird activity at lower frequencies, right? So at 6 a.m., probably there's like a cacophony of sound that's just erupt in a forest, which is just fascinating to hear. And you hear all these birds vocalizing at frequencies ranging from, somewhere between 200 hertz to going all the way up to 10,000 hertz. So you can see that darker colors represent higher activity. So there's quite a bit of activity happening early on in the morning, suggesting that there's a lot of bird activity happening there. And if you go further later in the day, you're probably hearing some bird activity towards the end of the day. So birds are probably getting ready to go back to their roost, and then finally it probably stops somewhere around 6 o'clock to 6:30, etc. At the same time, there's quite a bit of insect activity that's happening at high frequencies that we are probably not able to hear, right? So you can see that from midnight to probably at about 5 o'clock, there's a lot of insect activity that's happening between 15,000 hertz to 24,000 hertz. And then all of a sudden it just stops. And again, the insect activity erupts again later on, midday onwards, like somewhere around 1 p.m. or something of that sort. And then again, it starts after 7 p.m. As I was looking at this particular analysis that we had done, what was fascinating to us was there's this period of almost zero activity between 5 a.m. to 6 a.m. and then again 6 p.m. to 7 p.m. And sometimes when I go to some of these sites to place these recorders early on, let's say I'm there at a site around 5:45, the forest is just really quiet. It's as though there's like a lull in activity. And then at 6 a.m. or slightly before 6 a.m., the birds just start vocalizing, and there's like this cacophony of sounds. And again, towards the end, towards around 6:30, etc., there's this lull in activity again before the nocturnal taxa take over. And the activity that you're seeing here, which we probably associate with a lot of bird activity, is actually insect activity at this low frequency, which I verified. So there's a lot more that needs to be done in terms of how acoustic space varies. So in fact, this graph that I show you is actually just from a single site, one of the protected area sites. But I think it would be really fascinating to see how this acoustic space varies as you go from a rainforest to a degraded forest to something that's currently being restored. And so that's something that we're currently working on. And in at the moment, we've actually been taking detailed habitat measurements and vegetation measurements as well, such as what tree species occur there, what's the girth of a particular tree at its breast height, what's the height of the tree, what's the canopy cover like. And we know that such vegetation measurements really impact what biodiversity you see in a given area. And we have plenty of literature to support the same thing. So with that, I just wanted to bring it back to talking about Project Dhvani and our long-term conservation goals. And as I mentioned earlier, one of our aims is to monitor biodiversity across these human-modified landscapes. And at present, since we've been collecting a lot of data and more importantly, annotating it, we hope to test the feasibility of an automated detection system, especially in central India, where poaching and other illegal activities such as logging of forests that aren't supposed to be logged occurs. And we hope that this can be used as an early warning system for stakeholders like the forest department to uh, uh, to inform them about any presence of illegal activity. Right? Of course, one of my primary goals is also to look at species-specific identification. I'm really curious to know how we can, take this forward and perhaps build a better deep learning network, especially for birds in India, uh, where we can actually throw in a lot of our annotated data and get a good system where you can actually perhaps use your phone and record some data, and it'll probably tell you, oh, you're hearing a Malabar whistling thrush, oh, you're hearing a scimitar babbler. That's the hope, but that's one of our long-term goals. And lastly, of course, community engagement in terms of talking about the science to a broad audience. And I'm really grateful that I'm able to talk about this through this forum today to a lot of people, and talk to people about this different perspective of looking at biodiversity, not just through a visual lens, but also through an acoustic lens. So with that, I wanted to acknowledge the whole Project Dhvani team. There are a lot of people I want to thank here. You all know who you are, so thank you so much for doing all the work you guys are doing. Our key stakeholders, the forest departments of Tamil Nadu and Madhya Pradesh, our collaborators, Nature Conservation Foundation, Foundation for Ecological Society, and ISO Tirupati, and most importantly, communities around the tiger reserves of Anamalai and Kanha National Park who've been, uh, who've been really, uh, we're really grateful to them for letting us work in this particular landscape as outsiders, and we're actually able to tap into their tremendous knowledge of the biodiversity, and actually they've been really helpful to us in terms of getting our work done. And lastly, our funding sources, thank you for supporting us, and thank you ICTS for having me here. And yeah, thank you. I'm happy to take questions.
Yeah, thanks, Vijay. And there are a lot of people interested in asking you questions. So I'll read them out one by one. So the first one is by Arush Murali, who asks, won't acoustics detect many more organisms and so reduce the apparent danger of loss of biodiversity?
If I understand this right, you're telling me that we can actually record not just birds but a lot of other biodiversity, and we can actually perhaps get at what we are trying to think of as the empty forest syndrome, which is perhaps we're losing a lot more insects faster than we're losing birds. Sure, yeah, acoustics can tell us that, and one way to look at it is the idea of acoustic space use, which is something we're working on, and perhaps a soundscape rather than just annotating birds might tell us a lot more about what's happening. Yeah, definitely.
Yeah, the second question is by Tanya. She asks, how is that only specific sounds that are needed to be heard are extracted from the rest of the noise?
Yeah, that's a great question. It's tricky, definitely. In fact, I was just talking to my colleague earlier today, Akshay, who's been annotating some of this data, and he said that in a given 10-second clip, he was able to identify 20 different bird species while there was a lorry passing through that given area. So it's definitely really tricky. I would say that, over time, when you spend more time in this landscape and learn more about the birds here, you sort of, your ears tend to start getting tuned to the birds you see. And now I think Akshay is tuned to even seeing the spectrograms and what the shape of their sound looks like. So yeah, I would say it just takes practice and, spending more time in this landscape.
Tanya also asked that how you actually record the song sounds, the biodiversity sounds, and how you analyze them. She's
Yeah,
interested about that.
Yeah, thanks, Tanya. So, in terms of how do we record them, as I mentioned earlier, we place these acoustic recorders. They're usually deployed for about, I've been deploying them for 4 minutes on at a stretch and then 1 minute off so that it writes to the memory card. So it's just a small device where, and I leave that on for 24 hours at a time for almost 7 days. But different people have different durations that they sample in. So in fact, you can probably just record 15 minutes or 20 minutes of the morning chorus and 20 minutes of the dusk chorus, depending on what your specific question is. We wanted to record the overall biodiversity because we wanted to look at the soundscape. In terms of analysis, we've been mostly relying on this open access programming language called R. So it's primarily used for statistical analysis and modeling. And we've been processing all that data through that, as well as this freely available graphical platform called Raven Pro that the Cornell Lab of Ornithology provides.
Yeah, the next question is the basic but the most necessary, I feel, to be very important question, and that is Kartikeya asks, what is meant by protected area?
Yeah, so that's a tricky question. So today, I think the definition of a protected area is primarily in terms of what the forest department defines as, the boundary of a given protected area. But there's been a lot of debates going back and forth with respect to the stakeholder you talk to. So if you're talking to local communities that reside around these areas, we know that there's been a lot of backlash with respect to the Forest Rights Act and in terms of their rights to the land that they've been residing in. But if you talk to a different stakeholder like the forest department, they might argue that we should probably conserve this area and perhaps add a fence around it. So I think I could go on and talk about the pros and cons of how we define a given protected area. There's a lot of literature coming from North America and South America where the idea of fencing a given area might have negative impacts on animal movement. So I would definitely look up more information on the Forest Rights Act, especially in India, to know more about how our definition of protected areas affecting people who live there as well as other stakeholders.
So Zenith has this question on whether the work that you do, as in collecting all these sounds, can be termed as sound mapping.
Yeah, I mean, sure, definitely. I mean, that's one way to look at it. In fact, our website that we launched last month, we have actually showcased samples of recordings from each of our sites. So you can actually log into the website and sort of have like a, go from the central India to the Western Ghats and hear all the sounds from different sites. Yes, definitely. Yeah, that's a great idea.
And Murli asks, is the reduction of bird activity in eucalyptus plantation because it is a non-native species?
That can be argued as definitely one of the reasons. We have a lot of literature that supports that, higher the diversity of the tree species, higher the diversity of bird species. There's a lot of literature from neotropics and Southeast Asia that support this argument. And in a similar vein, my colleague Priyanka, she's been doing some work in Valparaiso where they have shown that, the number of tree species, and not just number of tree species, the differences in tree species between a protected area site or a restored site and a timber plantation, which primarily consists of eucalyptus and other invasives, is actually associated with the difference in bird species that you see between these sites. So yeah, definitely the composition or the identity of a particular tree species has an impact on the birds that you might see there.
Sarmishta asks, how can you differentiate the sounds of birds, that is the different species, from other sounds of animals which are also present in the same habitat?
Right. Yeah, as I mentioned earlier, I think it's a matter of learning what what calls different species make. Sometimes even ecologists, friends of mine, have said that, hey, I'm hearing a greater cuckoo, which you might hear in a lot of cities in India, right? But when you come to some of these more pristine forested areas in the Western Ghats, you're probably also hearing a Nilgiri langur, which sometimes sounds very similar. So I think it just takes a matter of time and tuning your ear to what different species sounds like.
Kartikeya has questions on the kind of equipment you use. So in your talk, you have mentioned two devices. The first one is a Swift recorder, and he wants to know what's the other one.
So the other one is the Audio Moth, which is the device that we've been primarily using. So it's manufactured by this team called Open Acoustic Devices. In fact, it was started by a team of uh, electronic engineers at Imperial College London, and I think they found that a lot of ecologists around the planet have tremendous use for a really small device and a compact device that can record biodiversity for long durations of time. So yeah.
Our colleague Juni from ICTS has this question on, do you have something like a should be soundscape for a particular area, where you something like a sound signature which you would expect a particular area to have at a particular time?
Yeah, no, that's a great question. I wish we had something like that, because one can also argue. So let me start by saying that there's this gentleman by the name of Bernie Cross, who has actually been recording a lot of sounds at the exact same site for the last 2 decades. So he's actually been seeing this shift in what that site sounded like in 1991 to what it sounds like now in 2011. So that being said, I feel like we are currently sort of establishing the baseline for what certain sites sounds like in the Western Ghats and Central India. And I think it's really high time that we do this, because habitat loss and climate change are here to dominate the rest of our century. And we would like to better understand, how we can perhaps uh, not protect, but arrive at a particular baseline that we recorded in, say, 2020. And going forward to 2025, we would like to see if that similar baseline exists. So yes, we are trying to establish that particular signature for different sites, but that will probably take some time. Yeah.
Kartikeya has a question on, do birds sound different at different times?
That's at different times. Well, definitely birds have different calls that they make depending on the interaction that they're currently perceiving, whether it's an alarm call or a contact call, or just a begging call. Sometimes certain birds make a begging call for food. Uh, and there's also, of course, the song, right? A lot of songbirds sing during breeding season. At different times, though, we haven't really seen that yet. But at the moment, we're currently trying to analyze data and trying to see, if the calls that different species make, especially a bird like the Malabar whistling thrush, does it vary as you really go from, like a protected area site to something that's a degraded patch? And why might that be the case if that's what we're going to see? But I haven't really come across, different. We definitely come across different calls at different times, but we haven't perceived it as sounding slightly different. But I could be wrong. Yeah.
Govinda wants to know, are there any potential threats to birds or the animals that you observe with the use of the instruments to record sounds?
Yeah. So I would say no. I don't think there are any threats to the existence of these devices, but we have noticed that some birds tend to get pretty curious. In fact, the Malabar whistling thrush. I have a beautiful recording of a Malabar whistling thrush coming really close to the recorder, sort of pecking at the recorder, and then vocalizing really loudly, and then you can hear it flap its wings and then fly away. So definitely, depending on the device you use, a Swift recorder, for instance, is pretty large, right? So it's conspicuous. But audio modes, for example, you can camouflage them pretty well in a given site. And we in fact have either Ziploc bags or better waterproof cases. So even if there's like a small light that's beeping, which shows that the recorder is currently recording data, even that light won't be perceived to the external environment, because of course there are a lot of moths and other insects which love certain light, right? So yeah, I would say I don't think so. And there hasn't been any data to support this argument yet, but it would be an interesting question on its own. Yeah.
Joni wants to know if there is something ongoing or future plans of involving the local community to monitor illegal activities in these areas.
I think we have a small technical issue. I think we just lost Vijay. Yes, he is in the Nilgiris, so we'll give him a few minutes to figure out his internet connection. In the meanwhile, I have also questions from the YouTube comments section. So once we have Vijay back with us, let's also ask him this question from the YouTube comments. Is that fine, Ipsita?
Yeah, sure.
Yeah. For everyone.
Sorry about you. My device just switched off. Can you guys hear me now? I'm just logging into my phone right now.
Absolutely. We can hear you. That's more important. Yeah.
Can we resume the question and answer session?
Yeah, definitely.
Yeah. So Vijay, I was asking. So Juni was asking whether there are any present efforts going on to involve the local community in monitoring illegal activities, or in the near future.
So I think across India, in fact, across a lot of especially tiger-centric landscapes, there is quite a bit of involvement of local communities. So in the case of the Animalize, the best example I can think of is that the Nature Conservation Foundation works with local communities, especially those of the Kadar tribe, and they've been around this landscape for centuries now, and they know the wildlife and the
I think we lost him again.
Considering that he's in the field in the middle of the Nilgiris, I'm quite surprised we had him for so long. But it's quite ironic that somebody who was an expert on bioacoustics and sounds is now at the mercy of audio technology. But participants, thank you so much for joining us. We have taken note of all the questions, and this is Cosmic Zoom. Ipsita, why did you take this opportunity to introduce the other events that are coming up? And I hope by then Vijay joins us soon.
Yes. Thank you, Bertie. Thank you, Vijay. I know he's not around, but thank you so much for such an interesting talk. And we'll make sure that these questions are sent to him and perhaps answered on the YouTube page. So the next talk is a very interesting one, and it will be tomorrow. It is by Project Malik and Lakshmi Joyce from Think Tank, and they'll be showing how their session is on learning with toys, hands-on science activities. So this is a very interactive session. So it is at 10:30 tomorrow morning. So please join us for this event. And you can also there are many more events planned in the next few weeks, and please visit our website to know more about them, or follow us on Instagram and Facebook, where we'll be posting more details about these events as the days come. And like I mentioned before, please do visit our website, www.cosmiczoom.in, and please go through the exhibits we have there. Yeah.
Thank you so much. And Vijay, we understand, we just got your message. Thank you so much for even agreeing to do this, and we've got so far, and that's very important. Just a quick interesting. So on YouTube, we have a few comments, including people like Abhinav Rajagopal and Kiran Mehta saying that this was really super interesting and fantastic, and a few questions, including those from Professor Ravi Chellam. So what I'm going to do is, if you don't mind, Vijay, I will pass on the questions to you, and I will just send them in word to you. You can record a video of yourself replying or responding to these messages, and we'll add that on to the YouTube video, which we will eventually put up on the website, so that it's one free flowing question session at that point of time. We can edit all these bits out. And those who are on YouTube, do not worry, your questions will be relayed to Vijay, and he will have enough time to think about it and reply, and you can see the replies eventually when the final video comes out. Is that okay with you, Vijay? You can reply on the message.
Yeah, that sounds great, Bertie. Yeah, I'm actually going to log into YouTube and try to reply to some of these questions.
That'll be amazing. Thank you. Okay, and that brings us to the end of the session. Here's a big shout out to everybody out there. Thank you for staying behind, and thank you for the amazing feedback that you're giving us. And we're looking forward to seeing you in all the events that are coming up. Do go check out, as Ipsita said, cosmic-zoom.in. We have events covering everything from honeybees to whales to the birth of stars, and please do come forward, and we'll be looking forward to seeing you on screen. And if there are mediators who are out there, you will get a mail soon. We are starting the mediator sessions on Sunday, and to everybody out there, what are mediator sessions? These are special Zoom sessions every day where you will get a personalized guided tour of the website, where these wonderful mediators will ask you questions and engage you and have a lovely conversation with you for 1 hour every day. And that will start hopefully on Sunday, definitely by Monday. So this is Bertie actually saying good evening and good night. Thank you for being part of this, and we'll end the session with this. Thank you, Vijay. Thank you, Prita. Thank you to everybody out there. Good night.